All right, well, we'll go ahead and get started. So, my name is Will Bowden. I'm the sales engineer for Interscan Corporation based here in Camas, Washington. And today, our webinar is going to discuss toxic gas detection in wastewater applications. I appreciate everyone's time in joining us for this webinar, and I hope that you are able to glean some more knowledge and we could possibly help you out with any applications that you have within your facility and organization. Right. So for Interscan, we like to say that we're easy to use, easy to own, specialized gas detection instrument. Interscan's been around since 1975 and provided toxic gas detection instruments for various applications, including wastewater, aerospace, industrial, etc. So we all understand that wastewater treatment plants can be an unwanted source of foul smells within neighborhoods. Yet they're a vital uh, part of everyday life in terms of health and environmentally safe communities. Uh, Inherent in their daily lives, lies potential for health and safety hazards for those working in these facilities to keep them functioning properly and efficiently. So there's various organizations and regulations that we have to work with daily. One of those being OSHA regulations for the workers that are working in these facilities. And we have specific OSHA guidelines for IDLH and PEL. And just to define these, IDLH is defined as immediate danger to life and health. And the PE levels that we'll discuss in this application would be the permissible exposure limits. Each gas has different parameters for these, and these will be available and part of the specific applications that we'll discuss. Obviously, those regulations are guidelines used for exposure events and possible accidents to make sure that our workers are safe and able to come home every day. Other environmental regulations that we have, state and federal government regulations, the EPA, Environmental Protection Agency, for example, as a federal organization, has their own regulations for emissions, but each state has a Department of Environmental Quality that may have their own above and beyond NIOSH standards. For example, the state of California does have some that are slightly stricter than the federal standards that are available. And then under EPA guidelines for emissions, not just for toxic gases, but EPA has additional guidelines for what they call greenhouse gases. For example, methane, carbon dioxide, etc. So the first gas that we'll go into is going to be chlorine. Chlorine, the PEL limit is 1 ppm, and the IDLH is 10 ppm. Chlorine's used in wastewater treatment plants is added to treated wastewater to kill any remaining microorganisms that may remain after the wastewater has gone through the complete treatment process before the water is released out into the environment, streams, rivers, etc. Chlorine is a potential source of asphyxiation events for workers that are in the facility, but chlorine can also damage equipment in higher concentrations. Mixed with water, it can create hydrochloric acid, which is very corrosive and can corrode and degrade piping systems in other items within the facility. Next item that we want to talk about is hydrogen sulfide, or as everybody calls H2S. personal exposure limit for H2S is 50 ppm, and the IDLH is 100 ppm. H2S is typically produced in digesters by biological reduction of sulfates and decomposition of organic material. H2S is also present in various concentrations, actually in the inlet wastewater coming into the plant. Again, is another source of asphyxiation. And again, H2S being in combination with moisture can create sulfuric acid, which can cause damage to equipment in higher concentrations. H2S is one of those that is present not just wastewater applications, but many other applications as well, oil and gas applications, industrial applications, et cetera. And it's one of those that just is one of the major causes of exposure events. The next gas we want to discuss is actually going to be ammonia. Ammonia has PEL of 50 ppm and IDLH of 300 ppm. Ammonia is present in the aeration process, and for ammonia measurements, typical ammonia measurements actually within the water are used to measure how efficient the bacteria are in converting the ammonia to nitrogen. It's also used in some cases for additional water purification. Ammonia is also present in the wastewater that's actually coming into the facility as well. Again, ammonia is a potential source for asphyxiation, an asphyxiation event with personnel. Next one that we would like to discuss is actually chlorine dioxide, or CLO2, as some in the industry will call it as another term. Personal exposure limit for that one is 0.1 ppm. IDLH is 5 ppm. CLO2, in conjunction with chlorine, can be added to wastewater to kill any remaining microorganisms at the end of the line before the treated water is released back into the environment. Again, streams, rivers, etc. It's another potential source of asphyxiation events. This could be within the tank facility where the CLO2 is stored. It could also be in enclosed environments, wells, etc., other storage areas where there's a potential for a possible leak in the system where chlorine dioxide can be released. One of the next items we have here is ozone. Ozone is not one of those that we hear about a lot in the water treatment side. Ozone is one of those. It's a greenhouse gas that we hear a lot about in the environment. We mentioned the ozone layer has been degraded over time due to greenhouse gas exposure from methane, chlorine, or carbon dioxide, et cetera. So in this particular application, the PEL of ozone is 0.1 ppm. The IDLH is 5 ppm. And in wastewater applications, ozone can be injected in wastewater as a disinfectant or a water polisher before it's discharged to external waterways. The potential situations and danger of ozone is that it is extremely irritating and possibly toxic at higher levels. And so it can be produced by off gas. So the off gases must be monitored for human safety and exposure risk. Again, typical application could be within the ozone storage tank area and also any enclosed process areas such as the one we have here, where we have systems in place inside of enclosed building with little to no ventilation. After we discuss the various applications and toxic gases that could be available within a wastewater treatment plant, now we want to discuss the instruments that Interscan provides for detection of these gases. First instrument that we have is actually our Gas D portable gas detector. Gas D is an integral sample pump powered by rechargeable lithium-ion battery. Can give up to 8 hours continuous service out and about in the facility. We do offer a standard general purpose product as well as an intrinsically safe product in the event that that is required. Normally, it isn't required in wastewater applications, but depending on either regulatory requirements or specific water authority or government agency requirements, that may be the case. And we do have that available if it's needed as an option. So with the Gas D, we actually have a digital readout of concentration along with real-time graphics display and internal data logging. The internal data logging actually comes from or comes via SD card slot here with up to 32 gigs of memory. And that's downloadable to be able to take that and move it over to a PC and it be able to extrapolate that data and do analysis on that. We have both audible and visual alarm that's built into the Gas D detector. And then in terms of analog outputs, we actually have terminal strips on the back. And so we could have a 4 to 20 milliamp and 0 to 2.5 volts DC output. The next tool in our arsenal is our AccuSafe fixed gas detector. With our AccuSafe, one control unit is very comfortable for up to 10 sensor units into the control module itself. Since the communication is actually via RS-485 Modbus, we can go up to 256 specific sensor modules. However, 10 is our sweet spot in terms of being able to navigate through the screen and through the different tabs that come up for each sensor module itself. The screen's roughly 5 inches and also includes the ability for remote web browser. Since we have that RS-485 communication protocol built in, you could take this and actually interrogate the instrument itself back at your laptop, desktop, wherever the case may be. Data acquisition is also built into the AccuSafe with 8 gig of data storage built in on board the control module itself. As I mentioned previously, communications via Modbus, TCP, and RTU, the RS-485. And then you have the ability to set up audible and email alarms. Email alarms, obviously, to be sent to email, someone's phone, etc., to be able to notify them that there is an issue that they can go back in and address. So with both our fixed and portable gas detectors, we offer our Sensor Express option. The Sensor Express option provides a new calibrated sensor ready to go out of the box to be installed in your instrument every 3 months. It's seamless sensor management, and with the interchange sensor system that's actually on the screen here, it's going to be external to the instruments themselves. It's quick, simple, toolless interchange to be able to remove the sensor module and replace that. They said our recommendation is 3 months to a year, depending on the gas. That again, that is gas dependent. Please feel free to contact us for more information on that, and we can give you the recommended schedule for that. So, and then it's maximizing safety by reducing that sensor replacement downtime. In other words, we know that every 3 months a sensor is going to come ready to go, pre-calibrated for that instrument, easy access, remove the old sensor, put the new sensor in, and off you go. Sensor replacement is one of those items that some organizations do lack on sometimes just because of the endeavors and the requirements for tooling, et cetera, scheduling to be able to remove sensors. The beauty of this being with our sensor exchange system is it's quick and easy, takes all of a minute. Now, in mentioning Sensor Express, it actually brings us to the topic of the sensor interchange itself. As you can see with the sensor module on top and the sensor adapter, it's simple, easy, quickly remove the sensor module and replace the plant into the sensor exchange. It ensures continuous monitoring and safety with minimal downtime. Again, a quick, 1 minute, remove the sensor, put in the replacement sensor, and off you go. This maximizes safety by reducing that sensor replacement downtime, where you may have additional tools where you actually have to go in and remove covers and things like that. The beauty of the sensor module that we have is on the exterior. It's very easy to get to. It's visually there. Like I said, remove the sensor, replace the new sensor, and off you go. So one item we wanted to discuss is customers come and say, to us and say, hey, we're looking at another product as well. And there's differences in the sampling. We have active sampling versus passive sampling. Active sampling, which is actually what Interscan uses in both of our products, requires a pump for sample transport. With that, we have flow rate variability because the pump has a variable speed. It's possible to collect the required sample over a preferred period of time. Again, depending on the application that you have, continuous monitoring or trigger mode, et cetera, each instrument can be set up for the requirements that each facility has. With active sampling, there's multiple active sampling methods that have been validated and published by government agencies. With the pump, being able to pull that sample in and run that through the system is going to lead to better response time, which is key, especially in the event of a leak of a toxic gas such as chlorine, ammonia, et cetera, where there could be personnel present in that area. We want to ensure that they have swift notification, so they can evacuate the area and initiate what their safety protocol for diagnosis and shut off of that particular leak. The other sampling parameter that we have is passive sampling. Passive sampling relies on the natural process of diffusion without the use of a pump. Many gas detectors that are out there rely on passive sampling, where a sensor is set up in an enclosure. It may have a filter to prevent water, insect, and particulate intrusion onto the sensor itself. The situation with that is an uncontrolled high sample rate intake or flow or volume can lead to overloading and high concentration. Many times I have discussed with customers, they had an event, the sensor got saturated with an excessive amount of gas due to a leak or an event that they had. So that can overload the sensor and cause premature degradation of the sensor. And then I always leave with the recommendation that sensor needs to be replaced due to the fact that it's been overloaded and its reliability has been reduced immensely. On the opposite end of the spectrum, an uncontrolled low sample intake, flow or volume, may not collect sufficient sample for detection if the concentrations are low. Now, when we say low concentrations, one of the benefits that we have with our InterScan products is we have the ability to measure down to parts per billion level, depending on the application that we have. So our typical measurement ranges can range from parts per billion up to parts per million. Again, it's application dependent and also instrument dependent, portable versus our fixed. With passive sampling, there's limited sampling methods that have been validated by government agencies. Officially, there's only two for passive sampling that were validated by NIOSH versus active sampling. Another feature that we have with both the GAS-D and the AccuSafe fixed gas detection system is data logging. On the GAS-D portable gas detector, we have data logging via the integral 32 gig SD card. That can be set up in the parameters in the system, downloaded to that SD card. That SD card can be removed, taken to a laptop or desktop. That data downloaded for analysis or regulatory requirements where the emissions must be documented and logged. And that is built into the instrument itself. AccuSafe, our fixed gas detection system, has 8 gig of data storage built in, but since we communicate via RS-485 Modbus, this can also be viewable through a remote web browser. And so on the screen of the AccuSafe itself, you have that display there, but then also have that backup of the data logging, again, for regulatory or environmental purposes, retention of that data per state, local, federal regulatory agency requirements. So finally, I just want to give a little bit of background on the history of InterScan. InterScan was actually established in 1975 and started out, some of the first customers were regulatory agencies, steel, chemical, petrochem facilities, and the customer base swiftly expanded from there. InterScan has a large presence in the defense and aerospace industry. And based on their work with the Air Force, InterScan was one of the first to develop a hydrazine sensor. This is typically found in what you call the copper galley, in terms of rockets, missiles, etc. Other milestones for special instruments for sulfur chloride, typically used in fumigation of buildings, and enhanced CO sensors for HP Medical, high performance formaldehyde sensors for Georgia Pacific. Now InterScan's products are globally present in various applications, and based on the electrochemical sensor principle, the InterScan has been that way from the beginning and has advanced the electrochemical technology into the products that we have today. So hopefully I didn't go through that too fast, but I wanted to see if anyone had any questions, any specific items that we would be able to answer. So our first question here is, why is active sampling better than passive? Well, active sampling is better than passive because we're actually utilizing the pump to be able to pull that sample in through the sensor, in a swifter manner. The benefit of this is a better response time And especially in those situations where the presence of toxic gases could be detrimental to the health and safety of the personnel that's around. You want the fastest response and the fastest notification of a possible event or higher levels that could be dangerous to life and health. Versus passive, you're relying on the laws of physics. In other words, you're relying on the laws of physics for that sample to just come in, and hopefully be exposed to the sensor that's built in, and hopefully that sensor is able to detect the presence of the toxic gas and give you a notification. The next question we have is, what is the lead time for getting a new device? Lead time is application dependent. For us, to get the most up to date and accurate lead time, please contact us and we can get that to you at the time of quotation. Next question is, can these detect multiple gases? In terms of our gas D product, our portable instrument, we can't detect multiple gases in a single instrument at the moment. That's something that we're looking at and researching and currently have R&D down the road. In terms of the AccuSafe fixed detection system, each sensor module is set up for a specific concentration, a specific gas. As I mentioned previously, the sweet spot is up to 10 sensor modules going into the control module, where it's easy to read and go through the menus and the tabs that are actually on the control unit. However, since we're communicating with RS-485, we can actually go up to 256 individual sensor modules that are controlled through a single control module. Next question we have is, how can I find a distributor in a country other than the US? And the answer to that is, please reach out to me and inquire where you're located, and we can assist in getting a distributor in touch with you. We can also assist in direct quotation to you, just depending on where your location is. Next question is, how often will I need to calibrate the device? There's really a few variables in there. Typically, our recommendation is every 3 months. However, it's dependent on the gases that are in play. It's also dependent on the sensor exposure to gas over a period of time. And what I mean by that is, for example, if we know that there could be chlorine that's going to always be present and in small concentrations, we may recommend calibration maybe every month. There's going to be situations like that. It's going to be case by case basis. Like I said, our recommendations every 3 months. But there could be extenuating circumstances where that may need to be more often. And we can discuss that in your specific application and the details of that. The next question I have is, can I view AccuSafe data from any computer in the world? And the answer is via the web portal or the remote web browser. The answer is yes. We have that set up. We can walk you through getting that set up where it can be interrogated from anywhere in the world. Again, via that communication through RS-485. All right, so it looks like I have addressed the questions that were available. So I want to thank you for the consideration of your time. Here's just some information here for us. Our web address is here. You you can schedule a consultation call with me, and we'll take this link and we'll put it in there in the chat. This slide deck will actually be going out to the attendees that have signed up for this webinar. And then for more information, you can contact me directly. My telephone number, email address is located on this slide deck. And again, to schedule a consultation, we have the link here, the Outlook link here. And if we can put that link in the chat as well, then we'll send that over. Feel free to reach out to us anytime. Thank you again for your time. Thank you for joining us. And we look forward to working with you on your gas detection application soon. Thanks. Have a good day.